So hello everyone, myself Ritesh Pandey. So today I will discuss the all four problems are bi-weekly contest 166 of LeetCode. So move on the first problem and see what it says. So let's see the first problem. So first of all, read the problem statement. So basically you are given a string yes consisting of lowercase English letter frequency group for a value k is the set of character that appears exactly k. The majority frequency group is the frequency group that contains the largest number of distinct characters. So basically, you are given a string yes, and it says that the frequency group for a value k is the set of characters that appears exactly k times. So it divides to the string yes into some frequency group, and it says that this set of character, let's say a character comes five times. So this is the set of then this character A will be part of the set, and the set of all that and the set of all the elements that comes five times will be present in that set. So move and see what other problem statement says. So return a string yes consisting of all characters in the majority frequency group in any order. If two or more frequency group tie for that large size, pick the group whose frequency k is larger. So basically it says you are given a string yes. So let's say the string is this. So say here you can write the string carefully. So say here and write the string. So the string is AA. So basically the string is AA means three times A. Wait a minute. Let's say string is like this. AABB. So let's say the string is AABB. So you need to construct the sets, some set of characters from this string yes. So see here the character A comes three times and the characters B two times. So there will be the a set of all the elements that comes three times. So there is a character. So there is a set of all the characters whose frequency will be three, and there is another set of all the characters whose frequency is two. That will be the two. So you need to find out the maximum frequency group, majority frequency group. So according to the problem, the majority frequency group is the group or set that contains the frequency with the largest that contains that contains the frequency of all the characters that comes k times, and the size of that string will be the bigger. So you can see here the set of all the the total number of the largest set means the total number of characters in both sets are equal. So if there is a tie situation, then you need to take that group that has the set of all the characters whose frequency is k will bigger. So you can see here the frequency of all the characters of this set is 2, and the frequency of all the characters of this set is 3. So you need to pick that set within the frequency of set of characters is greater. So you will pick A, and A will be the your majority frequency group. So you need to return the all the characters of the majority frequency group uh, and concatenate to all the character of majority frequency group in any order. So you will pick two. to this set and concatenate to all the characters into a string. So there is only one element. So your string will be so your final string will be A. So for this problem, your answer will be the A. So you can see, and you can also analyze with time complexity. So here the constraint is very simple, pretty simple. So which is the maximum size of the string is 100. So you can go either we go of n square, we go of n, and we go of n cube. So let's see here. So you can solve to this problem into big O of n, big O of n square, and big O of n cube. So I will solve this problem into the big O of n square. You can also solve this problem in other time complexity that can be fulfilled. So pick to the first test case and see how I can apply to this approach. So pick to this input testing, first input testing, and let's analyze it. So the string is so in this string, the A comes three times. Now B comes also three times. So now B comes also three times, and C comes two times. D comes four times. So you can see here D comes four times, and E comes one times. So basically our string is like this, and you can see the occurrence of all the characters in string. Yes, so you can also put here right here so that you can understand carefully. So the character A comes three times, the character B comes four times, the character C comes two times, the character C comes two times, the character D comes four times, and the character C comes one time. So here is some mistake. The characters B comes also three times. So you need to find out the maximum frequency group. So basically the maximum frequency of how you can calculate. You need to find the sum set of characters whose frequency is equal. Frequency of occurrence of all the characters is equal. So let's say I want to find out this frequency of all the characters. The frequency of all the characters that comes one time. So basically, I want to find the set of all the characters that comes exactly one time. So there is only one element E that comes one time. So you can see here there is only one character E that comes one time. So the set for this value of k will be the one, and I want to find out the set of all the characters that comes two times. So the set of all the characters that comes two times is only C. So for this value of k, uh, set will be the only C. So now I will find the set of all the characters that comes two times. So for this, how many elements comes two times? There is no elements come two times. So the set will be the empty for this value of k. Now I want to find out the set of all the characters that comes three times. So the set of all the characters that comes three times, there will be the two characters A and B, and also now I will find out the set of all the characters that comes four times. So we need to find out the set of all the characters that comes four times. There will be the only one character D that comes four times. So you need to find out the that set whose size is bigger. So there is the set A comma B that size is 2, which is the bigger from other sets, and this set will be the majority frequency group or majority frequency set. So you need to return an string that formed by the concatenating of all the characters of that set. So if you will print the string A plus A and AB that is formed by concatenating this string. So let's say if there is other value of k at value of k equals to 5, then there is an other set. Let's say in this set the characters F, F and G. The characters F and G comes 5 times. So there is two majority frequency group. Basically, there is two set that has the equal number of elements. So in this case, you need to choose that set which value of k is bigger. So how you can think to this and how you can implement to it. So let's say here how you can implement to this. So see this test case. Let's say so the test case is like this. So you can take the simple test cases. Let's say I will take the simple test case. Let's say A, B, triple A, and the BB. So now what I will do first, I will count the store the count of each character. So let's say the character A comes 3 times, the character B comes 2 times. Now I will go from each elements and I will find the how many characters that comes k times, exactly k times. So how many elements comes 1 time? There will be the zero elements. How many elements that comes 2 times? So there is the only one element. How many characters that comes 3 times? So there is only one element. So for each k equals to 1 to n, what I will do, I will find the how many elements that comes, how many element that comes exactly k times. How many elements that comes k times? That comes k times. And if anywhere this element, this number of element is, let's say this is the k, is greater than our the previous finded element. So what we need to update? So in this case, our majority frequency group will be the next finded group, next found group, which will be the this set of group. So for this, I will just uh, find our the count key, that how many the number of elements come in our the majority frequency group. So I will update to the C, means I will update to the maximum, not C. So I will update to our the maximum by this way. And now what I will do, and also I will update to the value of k, means I will take a variable, let's say index, or you can also take anything. How I will do this, let's say at any point the two set has the equal number of elements. So you need to select that the elements that has the maximum value of k. So also I will take an index and I will update to that index that is stored to the correct set of all the characters that comes k times. So basically index will store the frequency of that set of characters. So I will update to the index by k. So now by this way, after it, let's say here. So here you can find the set of all the characters that comes exactly 2 times, and set of all the characters that comes exactly 3 times. So for this count will be the 1, and the value of index will be the 3. So after it, you will find the how many the correct. So after it, you can see the number of elements in the majority frequency group will be the 1, and which value of k will be the 3. So for this, what I will do, I will simply find all the characters which frequency will be the 3 and concatenate to that into the string. So for here, you can only see this majority frequency group has only one character A, and so I will take a empty string and you will simply concatenate to this A and return our answer. So move on the code and let's see how it works. So this is the our code. So first of all, this is the function in which you need to implement codes. So basically, it takes a string yes and is the length of a string, and to count the frequency of each characters, I will take a map and I will put all the characters into the map, and I will take a array, which is the pair of character command you can see here. So that array will string this all the elements in this form, all the characters in this form. So let's say here A comes three times, B comes two times. So all these characters comes in this form in the array ARR. And now I will uh, I will put all the characters in that format in ARR, which is the array. And basically, I will sort to the array. How I will sort to the array on the basis of CMP, means on the basis of second element. So basically, in this way, all the characters sort in the based on our the occurrence of characters, means which occurrence of characters, the characters whose occurrence is lesser, that comes will first. And I will move on each character, and I will move on each element. Let's say how many characters comes one times, how many characters comes two times, how many characters till n. And for each occurrence of characters, I will move and find how many elements that comes exactly j times. And by this way, I will find the that all the count of all the elements that comes exactly k times, and I will update to the maximum according to the previous discussion. You can see from there, I explain here that how you will update to our the count and index. Now I will take a string yes, and I will find all the characters that comes exactly k times and put it into that string, and I will return to that string. So that is all for first problem. Now I will move on second problem, and let's see what it says. So now move on the second problem, and let's see what it says. So move on the second problem, and first is the problem statement. So basically, it says you are given a, wait a minute. So basically, it says you are given a step with n plus one step numbered from 0 to n. You are also given a one index integer, a cost of length n, where the cost of I is the cost of step I. From step I, you can just only to step j, I plus 1, I plus 2, or I plus 3. The cost of jumping from step I to step j is defined as the cost of j plus j minus I whole square. You start from step 0 with cost 0, return the minimum total cost to reach step. And so basically what I say, so it says initially you are at step 0. So initially you are at step 0 and you need to move go on the step n. So basically you are initially at step 0 and you need to go on the step n. So for this you need to move n plus 1 step. So you need from step 0, you need to move n plus 1 step. For this, uh, if you are at any step I, so from here you can only move on I plus 1 steps, I plus 2 step, or either I plus 3 steps. So let's say you will move on any steps from step I, either I plus 1, I plus 2, or I plus 3. So let's say this moment will be j. So the cost of this moment will be the cost of j. So the cost of this moment will be the cost of j plus the power of 2 of j minus I. So you need to minimize this cost so that you reach from 0 to n. So basically you need to find the minimum cost to reach from step 0 to step n. So what you can do for it? Thank you. So the problem is pretty simple. So let's say if you are at any step 1 I, then you can move on this steps. There is only three possibility. So let's say initially you are at 0 step, that is given by the problem. So from 0 step you can either move on first step, 2 step, and 3 step. Let's say if you move on first step, so after it you can only move on the third step, either fourth step. So let's say if you move on the third step, so from here you can either move on the fourth step, fifth stage, or at sixth step. So from this, you need to find out the minimum cost to reach from the zero to n step. So think uh, think that what you can apply on this. So first of all, see the question and think about the time complexity at which you can solve this problem. So the question is the value of n is from 0 to 10 to the power 5. So the size of array is 10 to the power 5. Now you can only submit to this problem in big O of n, either big O of n log n. So I will solve to this problem in big O of n. You can also find any solution in big O of n log n and submit to this problem from that approach. So how you can think to this problem? Let's say pick to this first test case. So find the find the minimum cost to reach from 0 to n step, where the cost of the array is like this. And from the problem you are at initially at 0 step, you are initially at step 0. So initially your step is 0. So now you need to move from step 0 to either 1 or 2 or 3. So you can move from step 0 to either 1, either 2, either 3. So let's say if you move from step 0 to step 1, so let's say you move from step 0 to 1. So for this, what will be the cost? Cost will be the cost of j, which is the cost of 1 plus the difference between the j and I. Basically, j is like this, means where you go from the step I. So for this, value of j is 1 minus value of I is the 0. So for this, cost of movement from 0 to 1 is 2. So let's say from here I move from step 1 to step 2. After it, I will move from step 1 to step 2. So what will be the cost of this? So the cost of this will be the cost of j. Cost of j is 2, and then the value of j minus I power 2, which will be the 2, plus the value of j will be the 2, and the value of 1 is the 1. So it will be the 2 minus 1, it will be the 1, that will be the 3. So after it, let's say I will move from the 2 to 4. There is only possibility of movement from step 2 to either you can move on the step 3 or step 4. Um, so let's say if I will move from step 2 to step 4. So for this, what I will do, the cost will be the cost of step j, which will be the 4. You can see from the here. And now the value of j minus I power 2 will be the 2 square. So for this, the value will be the cost of this will be the 8. So the total minimum cost you will get will be the 15. There is also some possibility to move from step 0 to step n, but it is granted as it will be the minimum. So you can verify to this from the given problem statement. Yeah, set. The minimum cost will be the 13. So you can see from the here, the sum of these three will be the 13. 8 plus 5 will be the 13, not 15. So how you can think to this problem? Think how you can apply some approach on this problem. So you can observe at any step I, let's say at any step I, there is three possibility to move. I plus 1, I plus 2, and I plus 3. So find all the possibilities at each step and find the optimal solution. So for optimal solution, you will always use DP And so here I will take a DP that store the answer of each step I. So here the DP, what DP of I store? So the DP of I will store the total number of the total minimum cost to reach at a step n from at a step I. And the DP of what? Let's say DP of one will store the minimum cost to reach from 0 to step I. So think here and apply the DP at each step I, and now I will find the minimum value at each step. So move on the code and let's see how you can apply to it. So basically this is the array which is the given. This is basically it is the cost array. I will name to this cost array as ARR, and I will take the DP of n plus 1 size. So basically I will initialize to the DP of 0 will be the 0, because if you are at cost 0, there will be because if you are at step 0, then the cost will be the 0, and move on each step. So let's say if you are at first step, so you can either move on the I plus 1 step or either I plus 2 step. So basically if you are I plus 1 step at from where you can reach from the I plus 1 step. So at ith step you can move from the I minus 1 or either I minus 2 or either I minus 3. You can move on the ith step. So you need to find out the two cost to this at ith step. You need to calculate the cost of the I minus 1th step plus j minus I minus 1th step. So if you this go from the I minus 2 to ith step, so you need to find the cost of which is from I minus 1 to ith step also. If you can go from the I minus 1th step to ith step, so you need to find this cost, and at each step you need to calculate the minimum of this all three. So basically if you are at the ith step, so you need to find the cost from the I minus 1th step that you can reach from the I minus 1th step to ith step, and also you need to find out also you can reach from the I minus 2th index step to ith step, or either you can reach from the I minus 3 index to ith step, and at each step I will take the minimum and store in the DP. After it I will return to the nth step with minimum cost. So that is all for second problem. Now I will move on the third problem and see what it says. So now move on third problem. So now move on third problem and see what it says. So first read the problem statement. So basically you are given a string S consisting of characters U, V, U of the LR representing moves on an infinite 2D plane. U means move from x comma y to x comma y plus 1, and like this. You are also given a positive integer k. So basically you are given a string S. Let's say the string S L is like this, L comma D. So the character D means L means you will, let's say if you at index x comma y, so from index from coordinate, let's say if you are at coordinate x comma y, so from the coordinate x comma y you will move from x minus 1 to y. So basically L means you will move from your current coordinate to left, one step left, and D means you move from your current coordinate to one step down, and U means you move from your current coordinate to one step upward in upward direction. So from x minus x comma y to x to y plus 1, and from R means you will move from your current coordinate to x comma x plus y comma 1, means from your current coordinate to one step in right direction. And you are also given a integer k, and you must choose and remove exactly one coordinate substring of length k from S. Then start from coordinate 0, comma 0 and perform the remaining move in order. Return an integer denoted in number of distinct final coordinates reachable. So basically it says you are given a string as, let's say string is like this, L and D. So you need, so for this you are also given a integer k, and you need to remove the exactly k size of substring from this string yes, and after it the you need to find the final coordinate of remaining substring, and after it you need to find out the how many distinct coordinates you will find. So basically let's say if we have a string like this LDU, and let's say the value of k is 1. So what we need to do, you need to share in more generalized way that what I said. Let's say the string is like this LDU and the value of k is 1. So you need to find exactly one size of this substring and need to remove this substring from your current string. So after removing this substring, I will get the string du. So after it, you need to perform operation on this from starting from coordinate 0 comma 0, means basically you are initially at 0 comma 0 and you need to apply this string operations on the 0 comma 0. After it, after performing all the operations on this string from starting from 0 comma 0, you will get uh, some coordinates. Means your final coordinate, let's say it will be the x comma y, and now you will find out the how many the coordinates are unique. So here I will get a coordinate x comma y, and let's say if after it I will remove to only this substring, not to L, only one length of substring we need to remove. So let's say if I will remove to this substring, so after it I will get the string LU. So after it I will calculate the final coordinate of this substring and ensure that you are starting your coordinates from 0 comma 0. Let's say if I will recharge at coordinate x1 comma y1, so I will get uh, two coordinates that will different from both if it both will not be equal. So after it, let's say if I will again remove to this, so after it I will get the string LD, and again I will find the coordinate of found by this string, final coordinate found by this string, and check it is unique or not. So after it you need to find the total number of distinct coordinate need to return. So see the question of this problem. So here you can see the size of string is 10 to the power 5. So you can solve to this problem either big O of n or big O of log n. I will solve to this problem in big O of n. And let's see how you can apply to this problem. Means how you can uh, think to this problem. Let's say the test case is like this LUL. So your string is LUL and the value of k is 1. So at each step you need to remove some substring. So whenever you need to remove substring, any substring, exactly k length substring, yeah, more than k length substring. So one step think about the sliding window. So let's say initially you have a k size window. So the k size window basically it of one size. So your window is from one to this. So in the sliding window, you will choose two indexes I and j, and I will take a window of k size, and after it I will move to that k size window in forward direction. So I will take the one side of the window, which is the L, and I will remove to this, and after it I will find the coordinate of next remaining string. So think about this. that how you can apply to a sliding window on this string. So your string is like this LUL, and you need to find remove the exactly one side of the substring. So basically, our initial I will take two pointer I and j to shift over the sliding window, which basically I will to move over the window. So initially our window size is k, that will be the fix. So I will take two pointer I and j, and what I will do, I will calculate the initially the coordinates of that window, that key size of the window. So initially I will present as the 0 comma 0. So here is the L. So from the 0 comma 0 I will only move on the left direction, that will I will move on the 0 comma 0. But if I will move on each window without on splitting over the window, means without our move to our window in forward direction, it will go on the big of n square. So how you can apply to it? So first of all, I will calculate uh, the final coordinate found by this whole string. So if I will form the coordinate found by the whole the string, what I will get? So initially, value of coordinate is 0 comma 0, and you are initially at 0th character. So you will move from here from -1 comma 0, and again you will move at second index here, and the character at this index is u. So you need to move on upward direction. You will get the -1 comma 1. So after it you will move on the this index, which will be the second index, and the value at this index will be the L. So you need to move on the left direction. So the final string, without removing any character or without removing any substring, you will get the final coordinate is like this. Means the final coordinate without removing any character will be the -2 comma 1. But you need to remove the exactly key size of the substring. So let's say I will choose to this substring. So you need to remove this coordinate from your uh, complete string coordinate. So you need to remove -1 comma 0 from the -2 comma 1. So I will remove to the -1 comma 0 from your coordinate -2 comma 1. So on removing to this, what I will do, I will subtract to this from it. Why I will subtract to it? Because if I will calculate to the coordinate of whole complete string, then after it we need to remove this uh, this substring from that coordinate. So if when I will calculate to the coordinate of complete substring, if I will when I will calculate to the coordinate of complete string, then we added to this substring, but now we need to remove this substring. So I will remove to this substring. I will get the new coordinate. What I will get? So I will get new coordinate will be the -1 comma 1. So I will get one coordinate, which will be the unique coordinate, which is the -1 comma 1. So now our count is the 1. So now I will move over the window, and now I will move on the J here, and also I will shrink over the window, because it is at this stage the our window size is become 2, but we need to only one side of the window. So now I will also need to split the window, means we need to shrink the window. But before shrink the window, what I will do, uh, uh, I will add the coordinate of this character into the, so sorry, we need to remove coordinate of this substring, means previous character I into the substring. Why I will do this? So in the previous window, our the coordinate is like this. You can see from there. In the previous window, our coordinate is -1 comma 0. But now we need to remove this character from that window. So to remove this window, so to remove this character from that existing window, you need to remove the -1 comma 0. So to remove the minus 1 comma 0, I will subtract to the coordinate minus 1 comma 0 from your existing coordinate of current window. So for this, your your window coordinate is 0 comma 0. So now we need to add this character into our the window, because after it our next window will be the uh, will be this window. So after it I will add to this window into our the current window. So in here our the window is 0 comma 0, and we need to add the coordinate found by this character. So I will add into our 0 comma 0, that is the current window coordinate. So I will add 0 comma 1 into the 0 comma 0. So now I will get our the new coordinate is the 0 comma 1, and again after it our the window coordinate is 0 comma 1, and now I will remove to this from a final coordinate, and I will again get the coordinate of new string that will be the that will get on subtracting our the final string coordinate and our the existing sliding window coordinate. So I will get again the minus 1 comma 0. You can also verify this from your uh, new string. You can see here, on removing the current window you will get the string ll. You will get string ll. So on apply on this, here you will get minus 1 comma 0, and here you will get minus 2 comma 0. And see here, there is some mistake. On subtracting 0 from minus 2, you will get minus 2, not minus 1. So our window will show our current the new string coordinate will be the minus 2 comma 0. So basically, I will summarize here what I will do. So here is the string L, and you are also given a integer k. So what I will do, I will take at each step. Firstly, I will calculate the coordinate of complete string. Let's say the coordinate of complete string is x comma y, and what I will do, I will find the coordinate of the current window. So let's say not the value of k is 1. Let's say the value of k is 2. Let's say the value of k is 2. So the current window is LU. So I will calculate the first I will calculate the coordinate of our initial window. So let's say our coordinate of initial window is x1 comma y1. So after it, what we need to do, we need to remove this window. So for this, I will subtract to our the final window in final window from this x1 comma y1. So we need to remove x comma y x1 comma y1 from your final coordinate x comma y. So for this, I will get our the final coordinate of new string. So basically, I will find the only the coordinate of this string I will find. So after it, we need to move over the window. So to move over the window, what I will do? So basically, in the previous, our window is from here, I is here, and J is there. Now we need to move over the window. So how I will move over the window? Let's say here. So if you move over the window, so now your window will become this. So for this, what we need to do? So for this, you need to first you need to remove this character from your existing sliding window coordinate and add to this character into your existing window coordinate. Means you need to remove the coordinate of this character I from your existing sliding window coordinate, and you need to remove the coordinate of this characters into your existing slide window coordinate x1 comma y1. So after it, you will get the coordinate of your remaining string by the subtracting the coordinate x1 comma y1 from your final string x comma y, and you need to find it is unique or not. So let's say after subtracting you will get a coordinate, let's say 5 comma 4. So you need to find is the 5 comma 4 is unique from your previous find it coordinate or not. If it is unique, then that is fine. If it's not unique, so you need to not do anything. So for this, I will take a map and I will put all your finded coordinate, and after it I will find the size of your map. So after it, I will return to the map of size. Let's see the code and see how I can implement it to this. So basically, I will take a map to find the total unique coordinates, and that I will find, and here n is the size of the string, and initially our the window is from I to j. So initially our I is at 0 index and j is at k minus 1th index, and initially the coordinate of our window is 0 comma 0, that is stored in the x and y, and our the final coordinate of whole string it will store in fx and fy, which is the final x coordinate of complete string and final y coordinate of string s. So basically, I will find the coordinate of a final string and store into the fx and fy. So I will take operation on the basis of the character I, and I will update over the fx and fy here. And here I will calculate over the coordinate of our window from I to j. So basically I will find over the coordinate of window from I to j, and at each window what I will do, I will put into that coordinate into the map. Before this, I will find the coordinate of your remaining string from subtracting your final string from your window string. You can see from here. I will subtract to this x1 comma y1 from x comma y, and after it I will put to this into your map, and after it we need to remove our the ith coordinate, and now we need to add your jth coordinate into our the existing map. So I will add our the ith coordinate, jth coordinate, and we need to remove ith coordinate here, and after it I will move over the ith pointer, means I will move over the window in forward direction, in right means in right direction. After it I will find the size of map that will give the total unique character. So that is all for third problem. Now move on the fourth problem and see what it says. So move on the fourth problem and see what it said. So first is the problem statement. So you are given a integer ARR nums. You want to maximize the alternating sum of num, which is defined as the value obtained by adding element at even index and subtracting element at odd index. That is this. You are also given a 2D integer array swap, where swap of I is the pi comma qi. For each pair pi comma qi in the swap, you are allowed to swap the element at indexes pi and qi. This swap can be performed a number of times and in any order. Return the maximum possible alternating sum of num. So basically, we are given an array nums. So basically, you are given an array nums, and you are also given a 2D integer array swap, and the swap then the each index of swap I is basically two elements pi comma qi. It means you can swap to the you can swap to the index py and qi of nums at any number of times. After performing this operation n number of times, you need to find out the alternating sum of array nums, and you need to maximize edge long edge to our the alternating sum of nums. And what it means of the alternative sum? Alternative sum of nums means the sum of all the elements at even index minus sum of all the elements at odd index. So now see the constant. So basically, your size of array nums is 10 to the power 5, and also the 2D array size swap of size 10 to the power 5. So you need to solve this problem in either big O of n or big O of n log n. I will solve to this problem in optimal way, and think how you can apply to this. So basically, pick the first test case. So the value of array num is like this 1 2 3, and your array swap is like this. Array swap is 0 comma 2, 0 comma 2, and 1 comma 2. Your array swap is 0 comma 2 and 1 comma 2. So basically, you need to find out your maximum alternative sum of array swap. So how you can think to this? So basically, if you will swap to the element 0 and 2, then again you can swap over the element 0 and 1. How? Let's say if you swap to the element 0 and 1, so after it you can also swap to the 1 and 2. So basically, let's say here, let's say you will swap to the 0 and 2. So it will become the 3 and 1. After it you can also swap to the 1 and 2. Also it you can swap to the 1 and 2. So basically, let's say if you swap to the 1 and 2, it will become the 3 1 2. So after it, let's say you will swap to the 0 and 1. So after it, you will get 1 3 2, and again after it, let's say you will swap to this 1 and 2. So you will get 1 2 3. So what is means of this? So basically, see here, what is means of, so what is means of this? So the means of this is you can swap to this either second or first element, or either second or third element, or either you can sorry, zeroth or second element, or either zeroth or one element. See here, here if you swap to again the 0 and 1 element, you will get this same element here. But here if you swap to the 0th and second index, you will get 2 1 3. Then what is means of this? So here you will see, you swap to the, you will swap second and first element that is given from here, and here you will swap to this zeroth and first element, zeroth and first element. So how you can see that uh, I will also swap to the zeroth and second index, also zeroth and one index, and also one and two index. So think about the graph. So the array is like this 1, 2, and 3, and our swap array is 0, comma 2 and 1, comma 2. So basically, this is swap array. So if you will swap to the 0 and 2, so 0 can swap with 2, and also 2 can swap with 1. Also 2 can swap with 1. So also you can swap to the 1 and 2. So also you can swap to the 1 and 2. Also 2 can swap with, also 2 can swap with 1, and also you can swap to the 0 by 1 after going on the adjacent of 0 to 2, and again going the adjacent of 2, you will get 1. So and you need to maximize over the alternative sum. So think greatly how you can maximize over the alternating sum. So for maximize over the alternating sum, you need to put as possible as minimum element at odd indexes, so that your alternative sum will maximum. So what I will do, I will go on the adjacent of each element from 0 to n minus 1. So let's say I will at the zeroth index, so I will go in the adjacent of zeroth index. So what will be the adjacent of zeroth index? The adjacent of zeroth index is 2. So I will go on the 2 and I will find the 3. So I will put into our periodic. Wait a minute. I will discuss why I use periodic. So I will go in the adjacent of 0, which will be the 2, and again I will go in the adjacent of 2. So in the adjacent of 2 again 0 and 1. So there is no need to go on the again 0, because I will go in the 0 previously, means I will visit to 0 and previously. So I will need to only go on the 1, and also I will go on the 1 and value I get 2. So it means I can swap to the element 0 with the element 1, or either with the element 2. So means I will can swap to the 0, means I will put to the at 0th index element 3 or element 2. And for one index, what I can put for also one index, I can put element either 3 or element 2. Also for two index, I can put this same element either 2 or either 3. How I will analyze? Also, if when I will go on the again the adjacent of 1, there is no need to go. So at each index either from 0 to 2, and also you view here at a 0th index the value is 1, so also we need to put 1. So what you see here means you will go, if you go on the adjacent of any element, so either you will put on that element at on ith index, or either any element that you visited from your index, from your adjacent of that index. So at the 0th index, either you can put 0 or 3 or 2, and also you can put at 0th and first and 2 index either 3 or 2 or either 1. So how you will decide to put which element at which index? So if the element is odd, means the index number is odd, so you need to put the minimum element. Why you need to put the minimum element? So because you need to find out the maximum value of your alternative sum. So to find out the maximum value of alternative sum, you need to put as possible as minimum element at odd index. So I will find out the how many the odd index in this adjacency. Means if I will go on the adjacent of each element I, each index I, so I will find out the how many odd indexes I found. So let's say if I will find the x element that is odd in that adjacent comes. So here the only one index 1 comes in the adjacent of 0. So I will put a minimum possible number at index 1. So here I will get only 3 number. So I will put first element means one minimum element, and I will subtract to this from your final answer. So we need to subtract this element from your final answer, because to find out when we need to find all the alternative sum, we need to subtract that element from your answer, and if element is at even index, we need to add. So after subtracting one element from your periodic row, I will add to this all the rest element into your periodic row. So here periodic will use, because you need to find out the first x minimum element that will place at odd index. So I will pop to the periodic row and one by one, uh, and subtract the first x element from your periodic row and pop first x element from a periodic and the subtract in answer, and after it rest element will add into the answer. So by this way our answer will be the maximum, means I will get the maximum alternative sum. So you can see from the here test case and analyze how it will be valid. So the arrays look like 0 1 1 2 3, and you can your swap array is like this. See here 0 comma 2 and 1 comma 3, sorry 1 comma 2. So in previously you said from 0 you will visit all the indexes. So after the 0th index, uh, after the going in the adjacent of 0 index, we not need to go on the other indexes. So you will get 1 2 3 and put all this into a periodic queue, and you will get the value of odd indexes is 1. So I will subtract to only one element from your periodic queue. So initially your answer is 0, and you need to subtract exactly one top element from your periodic queue, which is the min. So after subtracting 1, you will subtract 1 from this, and we need to add the rest of its element in periodic queue. So you will get maximum 4. You can verify this answer from your given problem. Yeah. So the final out answer is 4. So now move on the code and see how I can implement to this. So first of all, the array nums is as ARR and BRR is your swap 2D array. So first of all, I will get the size of both arrays, and I will initialize your final answer by f answer, and I will take over the uh, min heap, and I will take an adjacency list. You can see this as an adjacency list from here. Yeah, this is your adjacency list. So this is your adjacency list. So basically, this your adjacency list that is shown by your adjacent vector. So I will form the adjacency list, and I will take a map to find the index is already visited or not, and I will move on each index from 0 to n minus 1, and if anywhere index is not visited, then I will put to that index into the queue, and I will go in the adjacent of each index. So I will pop to this index, and if that index is odd, so we need to uh, increase your count. That will give how many odd index come on that index adjacent of that index I. So now I will go in the adjacent of that index, that is the f, and if anywhere the adjacent index is not visited, so I will put into the map, and I will mark as visited to that index, and after it I will take first C element, means which is the first x odd element, and subtract to that from your answer, and at each index at each time of answer after subtracting I will decrease over the count of odd indexes. And if the count indexes is become 0, means you will take all over the odd indexes, so only even indexes comes. So you need to add your top, means you need to add over the value. So after it you will add to your answer in the final answer. So after it you will return your answer. So summarize to this. So basically, I will here the two array ARR and BRI is edge your swap array. After it, I will take a periodic queue, which is the main heap, and adjacency list. I will form adjacency list, yes, and I will take map for your visited array. That gives the uh, status of your current index, that is already visited or not, and I will move on each index and see if anywhere index is not visited, index I is not visited, then I will go on that index, and basically after putting that index in periodic I will go adjacent of that index, and one by one I will move on each adjacent element of that index I, and I will see if anywhere that index is not visited, so I will put into the periodic and mark as visited, and see here if your current index is odd, means you will get the odd element, so increase your count, and after it, if I will pick the first uh, odd number of elements, that odd number of index element that comes in that adjacent, and I will subtract to that number of elements, top that number of elements from your answer, and add to this, and after it the remaining element will add into the answer. After it I will add to this current answer into your final answer, and after it I will return your final answer. So that is all for today. So thank you everyone.